All right, we are looking at question 5 from homework 5.3. All right, so the first part of the question right here is simple. So let's read. USA Today reported that about 20% of all people in the United States are illiterate. Suppose you take 8 people at random off a city street. Find the mean and standard deviation of the probability distribution. All right, so first things first, your mean. First and foremost, you have to establish what we're doing right here. So x right here is whether or not a person is illiterate or not. So is right. In this example right here, x follows a binomial distribution. N is going to be the 8 people, and then P is going to be 0.2. That's the probability that a random person chosen would be illiterate. All right, so find the mean standard deviation. Well, the mean has the formula. It is NP. And so in this, that's going to be 8 multiplied by 0.2. 8 times 2 is 16. That's going to be 1.6. So that's number A. And then find the standard deviation. The standard deviation is NPQ. And then take the square root. And just a reminder that Q is equals to 1 minus P. So in this example right here, Q is going to be 80% since P is 20%. 1 minus 0.2, that's going to be 0.8. Therefore, the standard deviation is going to be 8 multiplied by 0.2 multiplied by 0.8, and then you take the square root of this whole thing, and that will give you the answer of 1.13. Now the next question is a trick question. It says find the expected number of people in the sample who are illiterate. That number right here, expected sample, so I guess I should write number B. So the expected value of x, this is the same as the mean, because the expected value is just the average. And so therefore it's the same formula in P, and therefore the same answer, 1.6. All right. The last question is one that we have to do in SALT, because we have to do, it's a quarter problem. So we have to do guessing and checking until we can get to the right answer. But first we have to set the problem up. All right, so first things first is asking us for how many. And that's why you see the answer right here is a number. It's an example. This example, they say the answer is going to be 10. We'll find out. So that's the first thing we need to keep in mind right here. Now, the next thing right here is that they say we want to be 87% sure. And so what that's telling me is that the answer to the problem is that the answer is going to be 0.87. That's the problem answer we're looking for. And so we're literally going to have to keep an eye out to see if we can get to that answer. The next thing right here says at least 7. And so it means that we're trying to find the answer to the probability that x is greater than or equal to 7, right? And of course, we know n, well, actually, n is what we're looking for. So we don't know what n is, how many people, but we know what p is. P is going to be, well, actually, what is p? To be sure, at least 7 people can read and write. 20% are illiterate. That means 80% can read and write. So you got to use a 0.8 probability. All right. So like I said, all of this needs to be done in SALT. So let's go over to our good friend SALT. Oh, where do you go? That's not our good friend SALT. Oh, this is the right place. I just need to go over right here. So again, we have to select binomial distribution. In this case right here, we're going to start out with a low number. They say they want at least 7 people, so we will start out with 7. right? And the probability of a success is going to be 80%, 0.8. And what we want is greater than or equal to, so we want a right-tailed test. So we want at least 7 people. So this right here is going to be 7. Come on. And you can see right here that if we have 7 people, in the trial, the probability is going to be 0.2. But we want this to get all the way up to 87%. And so what happens is we need to put more people in the trial. And so what happens is we're going to come in here and we're going to increase this to 8. See, when we increase it to 8, the probability has gone up to already 50%. But that's still not high. We try and get it to 87%. So we're going to make this 9. That's 73%. We make this 10. And so we get 87.9, which is higher than 87%. And so what happens is we need to have 10 people in our sample. So again, this is a guess and check. We keep trying until we get the first number. We keep increasing by ones until we get the first time the probability. Until we get the first time the probability down here is greater than 87%. So 10 is the smallest number. Any number greater than this will be greater than 87%. But 10 is the smallest number. If I go to 11 or 12, you can see the answer is going to be higher than 87%. But 10 is the first time it goes higher. And so that's why they have 10 right here as the answer.